In this lecture, we'll be learning about a very popular machine learning model, what we call a decision tree model. So to let you guys know, because you guys are already aware of the KNN model and what you call these are non-parametric in-memory model, because we have to keep our data points active in the memory. And decision tree is another example of this kind of non-parametric model. Okay. So I think if you are with the computer science background, then you have some idea about binary search tree. You already have some idea that how do you split your data. So for example, given these data points, you organize your data in a kind of tree-based format, okay, or tree-based structure. You started with 8 and some data points are going to the left side and some others are going to the right side. Okay, so if you pay attention, we are seeing that at each node we are dividing the data. Okay, so this is the general idea of a tree-based model. So we will apply this same in this specific machine learning model. Okay, we will learn the basic concepts and the principles of decision tree through an example. Okay, let's say we are given these data points and the data points are mainly about two classes of animals, bunny and cat. So the features are number of legs and their corresponding weight. So we have to learn a tree-based model that will be able to classify a new incoming data point. Okay, so that's the general idea. Okay. So just like the binary search tree, we start with a root node. Okay, so the first node we call it as a root node here. Okay, so you have a root node where you place all your data points. So I am labeling B as bunny and then cat as C. Okay, so you see like bunny, cat, and bunny. Okay, so we start with all the data points. Okay, so now the question is that which feature will you use to split your data points? Okay, so if you pay attention to the number of legs, both the bunny and the cat, they have 4 legs. Okay, so there is no variation in the data. Okay, so this is a kind of useless feature. Okay, because you need to actually do your classification based on some criteria, and you are quickly identified that number of legs is not going to help. Okay, so the remaining feature weight is our only option. Okay, and if you pay attention, you see there are some variation in the data point feature values. Okay, so this is good. So let's first plot these data points. Okay, so the first bunny with a 2.1 lb weight, so put it here, and then the next is cat goes here, and then bunny goes here, and the next cat goes here, and then next bunny goes here. So as soon as you plot your data points, you quickly see that there are 2 clusters growing up. Okay, and the left clusters with weight around 2 and maybe 2 to 3, or maybe starting from 1.5 to 3.5, you have a cluster of bunnies. And the same, the chickens has something around 6.5 to 9 plus. Okay, so you see like clearly 2 clusters are growing. Okay, so what you have to do the next is to identify a split point. Okay, so you can choose any point between these 2 clusters, and let's say we choose the threshold point to be 6. Okay, so as soon as you have identified the threshold point, then you will actually propagate these data points to their corresponding left and right nodes. Okay, so that's the idea. Okay, so if you pay attention, then this bunny will go to the left, this cat will go to the right, given that you chose 6 as your splitting point. So you can clearly see that these 2 cats will go to the right and these bunnies will go to the left. So that's the idea. Okay, so as soon as you have identified this split point, you don't need to put your data points in its corresponding node. You just need to actually store those split point threshold values. Okay, And then your data points will be in your leaf node, okay? Okay, so let's say for some reason you actually chose the split point to be 2.5, okay? So you can clearly see that this bunny won't be able to go to its corresponding cluster, okay? So one of the bunnies will go to the right cluster, but still okay, because you will learn that you not always need to perfectly split the data, okay? So just to clarify that if you choose a threshold point 2.5, then the configuration will be something like this, okay? So you store the threshold point 2.5, then you will have two bunnies in your left node and the two chickens and one bunny at your right node. But this is actually to learn how we are splitting data and creating nodes for a decision tree, okay? So one question is that what metrics are used for split point determination, okay? So here I'm not going to the depth of these mathematical matrices. If you are interested, you should read some documentation in the reading list that we have provided, okay? So entropy, then Gini impurity, information gain, these are some of the usual matrices that are used to identify these split points, okay? We will go for a configuration with little bit more data. If you see, we had 5 data points and we had a tree that we have already seen here. Now we added a few more data points, okay? So 2 new chicken and they have 2 legs and they have their own weight, okay? We'll do the same exercise that we have done for our previous case with these 5 data points, okay? So we'll start with our root node. Here we have all the 7 data points and then we have a threshold point 6. So you can clearly see that the chickens are less than 6 in terms of weight. So they will move with the bunnies, okay, right? So they go to the left node and then two cats go to the right node, okay? Now in our left node we have 3 bunnies and 2 chickens. And if you pay attention, you see that now number of legs have some variations, okay? Some animals have 4 legs while some others have 2 legs. So now we will use a number of legs as our next splitting feature. And if we choose the split point to be 3 legs, then the chicken will move to the left and then the bunnies will move to the right, okay? So that's the idea. So now we have a complete tree that have all the data points being perfectly classified. Here the cat, here you have the chicken, and here you have the bunnies, okay? So now we have a new data point with number of legs 2 and weight 4 lb. What will be its corresponding level, okay? So how do you do that? The root node has weight threshold as its splitting criteria. The test point has 4 lb as its weight and 4 is less than 6, so the data point will move to the left node for the second check. And you have 2 as its leg. 2 is less than 3, so it will move to this node, and we found 2 chickens are there, so we can just label the data point as chicken, okay? One thing is for our data points, we were using this particular tree, but that was the not only tree that you would have learned, okay? So this was our tree that we have just seen, but let's say you started with splitting the data point first by using the number of legs, okay? And the threshold point was 3. So the chicken will be your first left node, and then all the other animals will move to the right side, okay? And then if you use the weight, then bunnies will move to the left node, and then the cats will move to the right node, okay? So for this particular setup, we might have generated 2 versions of trees, okay? And both are actually correct. One good thing with the decision tree classifier is you can generate many trees by randomizing your data and your feature combination. And how do you do that? let's imagine that you have given a data point, so you can sample any part of the data and create a tree. Okay, you can also sample features. Okay, so for example, your data set, although our example was with 2 features, but let's say you have a data set with 10 features or maybe 100 features. So imagine that you can do any combination of features to learn one specific tree. The main idea is that you can randomize your data to generate as many tree as you want. That was the basic idea of descent model. Here we were looking at an example for a classification task, but let's say you were to predict not the animal level, but let's say their height. Okay, so the animal height was your level column, and you will find here we were looking at the levels at the leaf node. So in that case, you would have their heights, okay, right? So let's say a given data point essentially ended up here. So what you have to do, you have to take an average of the heights of the bunnies. So that will be its corresponding height, okay? So you can use the same mechanism to do both classification and regression. That is the basic principle, okay? If you have any question, feel free to ask.